Today my topic is phase retardation plates. These phase retardation plates, generally the retardation plates resolves a polarized light beam into two orthogonal components, retards the phase of one component to another, and then recombines the two of two to form a single beam with new polarization characteristics. That means when a polarized light incidents on the particular crystal, suppose this is a calcite crystal, we have to cut a calcite crystal parallel to its optic axis. Whenever a polarized light incident on this surface, then it resolves into two components. One is ordinary ray, another one is extraordinary ray. Now it forms this ordinary ray and extraordinary ray into two orthogonal components, this device, and it forms the combined effect of these two rays. So if a light ray incident like this, a polarized beam, then this is called an ordinary ray and this is called an extraordinary ray. This device generally makes the path difference between these two rays. That is called the phase retardation plates. Actually, if a path difference forms, then phase difference also develops. So this is the thickness of the crystal. Then these phase retardation plates are classified into two types. One is quarter wave plate, another one is half wave plate. So the quarter wave plate means the crystal plate introduces the phase difference pi by 2 radians or the path difference of lambda by 4 between O ray and E ray. That means ordinary ray and extraordinary ray is called quarter wave plate. Suppose the path difference should be lambda by 4 between ordinary ray and extraordinary ray. Then this type of plate is called quarter wave plate. It is used to produce a circular or elliptical polarized light. Let us consider a calcite crystal and cut it parallel to its optic axis, and then a polarized light incident on it. That then or connect a output of nickel prism. Then a polarized light enters into this crystal, and this O ray and E ray follows the same path. These dots and arrows represents ordinary and extraordinary rays. So this is O ray, this is E ray, extraordinary ray. So it follows this path like this. Now I have to maintain the path difference should be lambda by 4. Suppose the mu naught and mu e, that means mu o and mu e, are refractive indices of O ray and E ray. Let us suppose then the path difference between this, the refractive index value with respect to the thickness is delta is equal to mu o into t minus mu e into t. Then delta is equal to mu o minus mu e into t, t as a common factor. This is equation number 1. This term with respect to the refractive index of the crystal and thickness of the crystal. Now we have to consider the path difference with respect to the ray which incident on this. Then for quarter wave plate, the path difference of O ray and E ray is delta is equal to lambda by 4. This is equation number 2. Now equate equation 1 and equation 2. We get mu O minus mu E into T is equal to lambda by 4. Then the thickness T is equal to lambda by 4 into mu O minus mu E. This equation this is for negative crystal. The example of negative crystal is calcite crystal. This equation holds good for negative crystal. So now T is equal to lambda by 4 into mu E minus mu O for positive crystals. The example is quartz. The best example is quartz crystal, which is positive. This quarter wave plate is used to produce a circular or elliptical polarized light. The next concept is half wave plate. An uniaxial crystal introduces phase difference between pi and path difference lambda by 2 between O ray and E ray is called half wave plate. This is similar to quarter wave plate. This quarter wave plate having 4 in the denominator, but in case of half wave plate 2 will be there in this equation. The same diagram, let mu O and mu E are the refractive indices of O ray and E ray, O ray and E ray. Then the path difference delta is equal to mu O into T minus mu E into T, where T is the thickness of the crystal. The same diagram. Then delta is equal to mu O minus mu E into T. This is equation number 1. Now the path difference between O ray and E ray, that is delta is equal to lambda by 2. This is equation number 2. Now equate these two equations. Equate equation 1 and equation 2. Mu O minus mu E into T is equal to lambda by 2. Then T is equal to lambda by 2 into, put this here, 2 into mu O minus mu E. This is for negative crystals. Similarly, the thickness T is equal to lambda by 2 into mu E minus mu O. This equation for positive crystals. Okay, this half wave plates are used to convert a given polarized light into plane polarized light. It is used to produce or convert a plane polarized light. That means the output of this half wave plate will be plane polarized light. The output of quarter wave plate will be either circular or elliptical polarized light. Okay, now we discuss about types of crystals, negative crystal and positive crystal. The crystals are classified into two types. One is negative crystal, another one is positive crystal. In negative crystal, the velocity of extraordinary ray is greater than velocity of ordinary ray. That means this is extraordinary ray, this is ordinary ray. This is the perimeter is less here, the perimeter is high. You have to, these two rays travels like this. These two rays comes out like this. They comes out like this. This is an ordinary ray, this is extraordinary ray. They follows the same path. To maintain the path difference between these two rays, extraordinary ray has to travel faster than ordinary ray because the perimeter is high for E ray. Then VE is greater than VO and mu O is greater than mu E. So for negative crystals. Here, in case of positive crystal, the velocity of ordinary ray is greater than the velocity of extraordinary ray. So that means this is elliptical shape, this is E ray, this is circular shape, this is O ray. Then the refractive index of extraordinary ray is greater than the refractive index of the ordinary ray here. So that's why we take these parameters in phase retardation plates. The example for negative crystal is calcite. The best example for negative crystal calcite. The positive crystal is quartz. The short answer question may ask like this: the types of crystals. So you have to draw these diagrams and write these parameters. This is enough for get marks. Okay, this is the important concept in polarization lesson. So you follow this, you'll be getting nearly 6 marks to 8 marks. This phase retardation plates may ask. Okay, thank you.